Hello friends, in this AV we are going to discuss or rather take a look at the half yearly question paper of ICSE class 9 physics that I have got from one of the schools after they have completed their half yearly exam. In case your school has not completed or you are yet to give your half yearly paper, then this AV might be a little helpful. Though the questions given here, I have a feeling is not very tough, but it is a okay paper. I think the examiner has set this paper keeping in mind that the students have gone through the 2 years of pandemic. So let's take a look at the questions. As you know that the first section here, section 1, all the questions are compulsory to attend. So we'll just take a look at all the questions. The first question says, a girl leaves her home, she travels in a car and returns home after covering 20 kilometers in half an hour. What is her average displacement? So here the girl from home goes to school and comes back to her home. So average displacement would be 0 because the initial and the final position are the same. The second question is, can the distance traveled by an object be smaller than the magnitude of its displacement? Straight cut answer is no. Here you can take a look in your book where they have talked about or where they have given the table of differences between distance and displacement. Okay, so this is a direct question from that table. Now, why does a rider fall forward when a galloping horse stops suddenly? This you can answer on the basis of inertia of motion. The whole body is in motion, and when the horse suddenly stops, the lower part of the body stops, but the upper part of the body still wants to be in motion. So due to inertia of motion, the rider falls forward. This is of the same nature. This question is of the same nature as of why does a passenger falls forward when a bus suddenly stops. Okay, so this can be answered on the basis of inertia of motion. The next question is, what do you understand by the term relative density of a substance? So when you compare the density of a substance with the density of water at 4 degrees Celsius, that is called the relative density of the substance. All direct questions here. What is meant by pressure and what is its SI unit? So here pressure, you know the formula, pressure is thrust per unit area, or we say force per unit area, and the SI unit would be Newton per meter square, which we call it as Pascal. The next question is, compare the time periods of two simple pendulums of length 1 meter and 16 meter at a place. Direct question from the third part of your first chapter. So we know that when we have to compare the time period, T1 upon T2 is equal to root upon L1 upon L2. For your kind information, this equation we are getting from T is equal to twice pi root L upon G. So the lengths are L1 is 1 meter and L2, let this be L1, this be L2. So 1 upon 16, that will be 1 upon 4. So this implies T1 is to T2 is nothing but 1 is to 4. Now the second question says, a pebble is thrown vertically upwards with an initial velocity of 50 meter per second, comes to a stop in 5 seconds, find the retardation. We know that retardation is negative acceleration. So the formula for acceleration is equal to v minus u divided by t. So here final velocity, this comes to a stop, is 0, minus initial velocity is 50 meter per second divided by time is 5 seconds. This numerical is very easy. So minus 50 upon 5, that is minus 10. This sign minus 10 meter per second square. The sign minus states or shows us that this is retardation. The next question is, why do sea divers need a special protective suit? This is directly given in the textbook. Basically, once they dive inside the sea, then the outside pressure becomes more than the blood pressure. You can just check this in chapter 4 or 5. This is a direct question. So due to that, they have to wear a special protective suit. The next question is, a ship submerges more as it sails from seawater to river water. Explain. Now this is, we know that the density of the seawater is much higher compared to the river water. So more the density, more will be the upthrust. So seawater gives more upthrust, whereas river water gives less of upthrust. That is why ship submerges more in river water. The next question is, name the SI unit of mass, that is kg, and time is second. This is again a direct question from the very first chapter. Now the third question says, state two uses of vernier caliper. You can just write to measure the diameter of a bob, or you can also measure the thickness of a glass or a rod. So any two uses you can write. This is another direct question. Now draw a displacement time graph for a boy going to school with uniform velocity. So you can just draw displacement and time, and since this is uniform velocity, so you'll get a straight line. Now icebergs floating in sea are dangerous for ships. Explain. This question is from chapter 5. So this is basically why, because 90% of the iceberg is below water, so it's very difficult for the driver of this ship to guess the actual size of the iceberg. That is why it's very dangerous. Now, why does a fountain pen leak at high altitude? So we know that at higher altitude the pressure decreases, so there is more pressure inside the fountain pen. That is why the ink flows from a higher pressure to a lower pressure area and it happens to leak. The next question says, dust particles are removed from the carpet by beating it. Explain. Direct question from the Newton's first law of motion. You will get it in your textbook. Please check. Now the fourth question says, this is the last question for section 1. It says, select the scalar and vector from the following. So velocity we all know, vector. Mass is a scalar quantity. Retardation is vector again, and work done is scalar quantity. So this is also directly from the textbook. Next question is, name the SI unit of force and define it. So we know that the SI unit of force is Newton, and the definition of Newton will be 1 Newton is the force which produces an acceleration of 1 meter per second square in a mass of 1 kg. Now the next question is, what is meant by the term, or what is meant by measurement? So measurement is basically the very first definition given in your textbook, the first red table or the first page of chapter 1. This basically means the comparison of a given quantity to the standard quantity of a or of the same nature. That is known as measurement. Now state Archimedes' principle. So Archimedes' principle states that when a body is submerged in a liquid, it is going to experience an upthrust, and that upthrust will be equal to the weight of the liquid displaced by the body, which means more you submerge it, more will be the upthrust. Now the last question of section 1 says, a dam has a broader wall at the bottom than at the top. Explain. We know that the pressure is equal to rho g h. So as we go at the bottom, height increases, and due to this increased height the pressure also increases. So if pressure increases, we need a thicker or a broader walls to stop the water or the pressure generated by the water. So this is another application based question, and you can say that this is also a direct question. Now going to section 2 of the question paper, the section 2 says we have to attempt any 4 questions from this section. Now this is of the board pattern. Now the first question of section 2, that is question number 5, says that define the term oscillation, amplitude, frequency as related to a simple pendulum. So 1 mark you get directly for one definition. Oscillation is one complete to and fro motion of the simple pendulum. Amplitude is the distance from the mean position to one of the extreme position is known as amplitude, and frequency is the number of oscillations made per unit time. You will get the definitions in the third portion of your first chapter, and this is another direct question. Differentiate between scalar and vector quantities. The table is given right in your textbook. Scalars are those which can be defined only on the basis of magnitude, and vectors require both magnitude and direction. Then there are certain examples, so you can just check the table. And since this is for 3 marks, it is advisable to give at least 3 points of differences. Now a body rises vertically up to a height of 125 meter in 5 seconds, then comes back to the point of projection. So here they are saying that the body is going up or 125 meter, and then it's coming down to the point of projection. So when it's coming down, it's covering another 125 meter. So they have asked the total distance. So total distance will be 125 plus 125, that is 250 meters. The displacement of course is going to be 0, because this is the starting point. Body is going up and coming down again to the same point. So since the starting or the initial and the final positions are the same, displacement is 0. Now average speed is total distance, that is 250 divided by total time. So 5 seconds. So 5 seconds for going up and another 5 seconds for coming down. So total is 10 seconds. So this will be 25 meter per second. Then the average velocity of the body. Now average velocity is going to be 0 again, because the formula for average velocity is displacement or total displacement upon total time. So total displacement is 0. So 0 upon 10 will give you 0 only. Now the next question, that is question number 6, says define the term inertia and state Newton's first law of motion. So inertia is the inherent property of a body which or by the virtue of which it cannot change its state of rest or state of motion by itself. It resists any change. So when an external force is applied, then only it is able to change its state of rest or state of motion. Now again, the first statement of Newton's first law of motion: a body at rest remains at rest, and a body in motion will continue to move along a straight line until and unless expelled by an external force to change its state of rest or motion. Please check this from your textbook. Another direct question. Next question is, a body initially at rest travels a distance of 100 meter in 5 seconds with a constant acceleration. Calculate the acceleration and the final velocity at the end of 5 seconds. So for acceleration here, what you can do is, we know the formula, S is equal to ut plus half at square. Now this whole term will be 0 because initial velocity is 0. Here they have clearly stated initially at rest. So S is the distance, that is 100 meter. So the equation becomes 100 is equal to 0 plus half acceleration we have to find out, and time is 5. So 5 square. So 100 is equal to 25a by 2. which implies 2 will be multiplied here. So 200 is equal to 25a. So from here a will be 200 divided by 25, that is equal to 8 meter per second square. So this is the acceleration. Once you know the acceleration, final velocity can be taken out using the formula acceleration is equal to v minus u upon t. Just put it, you will get it as 8 is equal to v minus 0 upon 540. So you will get the final velocity as 40 meter per second. Differentiate between distance and displacement. Direct question from the book. You have a table given in chapter 2. Please check that. Now the next question is define fundamental unit and derived unit. Fundamental units are those units which are independent of other units, and derived units are those which are dependent on fundamental units. You should give some examples because this question contains 3 marks. And the next question is, what do you understand by the term upthrust of a fluid? State its SI unit. SI unit is Newton because upthrust is also a force. What is upthrust? Whenever a body is dipped in a liquid, we experience an upward force, which is known as upthrust. Now the third question is, explain the following. It is easier to cut with a sharp knife than with a blunt one. We know that pressure is equal to force per unit area. So, pressure is force per unit area will be better suited for this. When you or you can explain this also with this, that since if we have to cut and we have a sharp knife, then the area is less, so with less pressure we can apply more force and it becomes easier to cut. The next question is, slippers are laid below the rails. Even this has got the same explanation, that when you place sleepers below the rails, sleepers have got more area, so the pressure that the rail engine or the body of the railway coach is going to exert will be divided amongst the bigger area, and the pressure due to that will decrease. Direct question from the textbook. Now next question, that is question number 8, says define force. You will find that they have talked about 2 effects of force, that it changes the shape and size, and it also changes the direction, or the state of rest or state of motion. So based on that you can define the force, or if required you may define from the second law of motion as well. Force is equal to mass into acceleration, and then give 2 examples of contact forces and non-contact forces. So direct question again. So for and friction for contact forces, and for non-contact forces you can just write magnetic forces, gravitational forces, all those. Now state 3 factors on which the pressure at a point in a liquid depends. So pressure is equal to rho gh, we know this formula. So pressure depends on the density of the liquid, the acceleration due to gravity, and height of the vessel or the place where the height or the depth of the liquid. Now differentiate between mass and weight. Again direct question. Mass is the amount of matter contained in a body, whereas weight is a product of mass and acceleration due to gravity. One is a scalar quantity, the other one is the vector quantity. Okay, so this remains constant and this changes with the changing value of acceleration due to gravity. If you write these 3 points, this should be sufficient. Then, or if required, you may take the help from your textbook, because you will find that there is a table given between the differences between mass and weight of the body. Now the next question says, name 2 factors on which the time period of a simple pendulum depends. So we know time period is equal to twice by root L upon G. So the first factor on which it's depending is root L. That means time period is dependent on square root of the effective length or you can say that time period is directly proportional to the square root of the effective length, and the second factor is time period is inversely proportional to the square root of acceleration due to gravity. And we have to write the relation for the time period in terms of the above named factor. So we can simply write T is directly proportional to root L and T is inversely proportional to root G. That is acceleration due to gravity. Now define linear momentum. You know that linear momentum is the product of mass and velocity. State its SI unit. SI unit is kg meter per second. Is it a scalar or a vector quantity? So of course, or obviously, it's a vector quantity. Now state Newton's law of gravitation. What is what is the importance of the law of gravitation? Now Newton's law of gravitation is the two bodies will pull each other with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So if m1 and m2 are the masses and r is the distance of separations, then F is equal to G m1 m2 divided by r square. Now what is the importance of law of gravitation? You can simply write that the tides that occurs in the ocean and sea, it's because of that the planets are moving around. That is also because of the law of gravitation. This topic is directly given in your textbook in form of points, so you can just refer to that as well. Now differentiate between speed and velocity. This is scalar, this is vector, this is distance by time, this is displacement by time. So all those things, just check the difference between the speed and velocity table from your textbook. Now this question, the force of attraction between two bodies at a certain separation is 10 Newton. What will be the force of attraction between them if the separation is reduced to half? Now this question is based on this one, law of gravitation. So here they have given, let's say that the first force F1 is equal to G m1 m2 upon r square. Now they are saying that this is equal to 10 Newton. So what will be the force if the separation is reduced to half? So let's say that is F2. So F2 will be acceleration due to the universal gravitational constant G remains the same. Mass of the bodies will remain the same. So m1 m2 divided by only the distance of separation, that is r, is changing and it's becoming r by 2. So square of this. So now this can be written as G m1 m2 upon r by 4. This 4 will go up. So we have 4 G m1 m2 upon r square. Now this whole thing is nothing but F1. So we can write 4 into F1, that is 4 multiplied by the value of F1 is 10, so that is 40 Newton will be your answer. So the force of attraction between them will be 40 newtons if the distance of separation is reduced to half. The last question says, explain the following. The cricketer pulls his hand back while catching the fast moving cricket ball. You can explain this on the basis of second law of motion. And a person falls down when he jumps out of a moving train. This can be explained on the basis of first law of motion, and you'll have to talk about inertia. So this is what we have, or we had, in this AV for you. I hope that this might help you for your upcoming exams. So thank you so much. Keep learning. God bless you all.